So I want to talk about combination versus permutation, how they're different, how you know what type of technique to use for what question, and how they can be misunderstood. Okay, so let's talk about permutation. You usually learn that first. So permutation, I'll just call it perm versus combination. I'll just call it combo. Okay, so what's the difference? Permutation is when order matters. Okay? That's when you care of what order things are coming in. Examples of that might be letters. It is unique of which way letters come from. For example, D-A-D is unique from D-D-A is unique from A-D-D. And I messed up. Okay. That's hard to see. So those are different ways you can write those same letters, okay? Well, how would you do that in a larger scale? How would you come up with, this is easy enough, I can just do 3, but what is a systematic way of doing that? A systematic way of doing that is to, first, let's just treat them as if they're all individual numbers, or individual letters, excuse me. What if you just treat them as if they're 3 letters, okay? So how many different ways can you put 3 letters in 3 slots? That's 3 times 2 times 1, right? We call that 3 factorial. Okay? 3 factorial. Alright. So that's if they were individual. That's if they were unique. But we have these duplicates. We have 2 D's here, right? Okay. So we need to come up with a way of not overcounting. And that 6 I had up here would have overcounted. So first, treat them as if they're all unique letters. And then see how many you're duplicating. Okay, so you're duplicating, you have 2 D's right here. So we need to divide by 2 factorial. Okay, so now you have 3 factorial over 2 factorial. That's 3 times 2 factorial over 2 factorial. There's 3 ways. We already knew that, but this is a systematic way of finding out how you do that. Always treat words with letters as a permutation. They're not combination. Order matters. It's unique of which way you put them. Okay? Now, combination. When do you use combination? You'll generally use combination for coins. You'll generally use combination for times that you're grouping things, putting people in groups, this type of thing. You don't care if you reach in your pocket and you get a quarter, a nickel, and a penny out. You don't care which order it came out, you just care that you have those things. This is a combination, and a combination helps us not overcount. Okay? It is essentially a permutation, reducing that overcounting. Here are the formulas. That's the combination, okay? Notice you have the n factorial, n minus r, and then quantity factorial, r factorial. That should be in your notes, that should be in your book, it should be somewhere, okay? Permutation is almost the same thing, but it doesn't have that same bottom, doesn't have the same denominator. So this is n minus r factorial r. Oh, no, that's not true. Okay. So it doesn't have this r factorial. This r factorial will reduce out that overcounting. Okay? This is if order matters. This is if order does not matter. Alright? Let's look at the same example, but two different ways. Okay? This has been on a lot of homework. Let's look at it. For both cases, let's say we have 7 Democrats and let's say we have, I don't know, 6 Republicans. Okay? Now, for the permutation case, let's say we are putting them in office. Maybe you put them in president, vice president, speaker. Okay? In the combination, you're putting them in groups or subcommittees. Okay? That's what to look for in those problems. So if you're putting them in subcommittees, we just want to count how many ways can you have subcommittees of 3. Okay? So we'll just say group of 3. Alright? Now this is very specific. Putting someone as a president is very different than putting someone as a speaker. That's completely different. Putting someone in a group is not so different after all. Okay. So let's think of if you want to do the total sample space. Okay? Total sample space. The total sample space, what do we got here? We got 13 politicians. Okay? We got 13 politicians. So the total sample space is going to be 13 times 12 times 11. Alright? For the total sample space of subcommittees of 3, that's going to be 13 choose 3. Okay? What if you're looking for ones that are just Democrat? Okay, so if you're looking for just Democrat, then here you're looking at 7 times 6 times 5. This is still for president, vice president, and speaker. If you want just Democrat here on the combo, you're looking at 7 choose 3. That's how many ways you can make groups of 3 of 7 people. Okay? What if you want just Republican? You probably can guess this one. 6, 5, 4. And you can probably guess this one. 6 choose 3. Okay? Now, here comes the thing that confuses people. What if you want to make sure that you have at least one person in that's Democrat or Republican? Okay? What if we need to guarantee that there's at least one Democrat and one Republican? You can do this in both questions. Alright, so the straightforward approach, the naive approach, is going to be counting all of the different ways you can do it straightforward. So you would go, well, have one Democrat here, and then the rest are Republican, or I might have a Democrat, Republican, or I might have a Republican, Democrat. This is going to take all day. You don't want to do that. You don't have to do that. Okay, when you see at least on your homework, on your exam, anything, think of this. Try to find what the complement is of what you're trying to find. We've already found the total sample space for both cases. Okay, this is the total sample space for this case. This is the total sample space for this case. Okay? So if you need to guarantee that you have one Democrat and one Republican, what can you do? Well, you can just take away what you don't want. And we found already what we don't want. We don't want a mono system. We don't want all Democrats, and we don't want all Republicans in the third part of this question. So what you can do is you can just take the sample space minus this number minus this number. And when I say this number, I mean this whole product. Okay? That's going to be the same for here. This is the universe. This is all Democrats. And this is all Republicans. Okay? So if you want a group that guarantees to have both parties, then you need to take the sample space minus the two monosystems. That will leave you with what you want. And then you don't have to come up with all the different ways. Combos, it's easier to do that. Combos, it won't take as long if you wanted to go the naive approach. But permutations can be kind of a headache, and generally with questions on exams, you only have, 2 minutes, 3 minutes, 1 minute to answer a question. So you don't want to have to do that. And you want to focus on questions that are more difficult than this. So that is my advice. I didn't multiply it out, but I don't think anyone's going to have a problem with that. If you do, let me know. So this is kind of an intro of what's going on with permutation combination. Permutations are words, letters, they are digits, product codes, these types of things. And putting people in specific roles in offices. If you have a question that talks about a play, and you're putting people in roles, that's going to be a permutation. If you have a question that talks about coins, if you have a question that talks about putting people in teams or subcommittees or groups, that's your combo. You got to use combination because you don't care about the order in which things are happening. You just care about that it happened at all and how many different ways can it happen. Okay? So I hope that helps. If it doesn't, let me know. And so just email me or comment on the video below, and I will see you later.